All right, so for this section, which is 5.3, we're going to take some real life examples of applications of exponents and applications of logarithms. And we're just going to do some basic interest problems. So one of the things that you need to know is normally we will say that interest is principal, which is what you start with, times rate times time. So principal is what you start with. So for instance, if you were going for a car loan and you needed $10,000, you would go to the bank and say, hey, can I have $10,000? And they'll say, here you go. So that's your principal. Your rate is always reported as a decimal. So don't think that just because it has a decimal in it, that it's actually a percent or actually a decimal form. So if I've got 5%, okay, what I need to do is move my decimal twice to the left. And so the decimal form of that percentage is 0.05. Okay, the decimal form of that percentage is 0.05. Now, what happens if I have something like 6.27%? Okay, yes, it has a decimal in it, but it's in percent form. It's not in decimal form. So once again, you're going to move that decimal place back twice, so you'll get 0.0627, and that will be your rate. Time is always going to be reported in years. So if you're only doing something for a partial amount of years, like just for 6 months, then time will be 1/2, because it's half of a year. So time is always going to be reported in years. This is simple interest, okay? And we can make it a little bit more exciting by saying, okay, the amount that I accumulate is going to be my principal plus the interest. So there's my principal, and there's my interest, because interest is PRT, okay? And so at the end of the loan, so I went to the bank and I said, hey, can I have $10,000? And they say, absolutely, sure, here you go. But at the end of the loan, you have to pay back $11,000. Okay, that means that there was $10,000 in principal and $1,000 in interest. So I can change that instead of just dealing with interest. And I can factor out P and change that to 1 plus RT. So this is the principal times 1 plus the interest rate. And now if we're going to go to compounding interest, which essentially means you're going to be paying interest on your interest. Okay, so a mortgage or a house loan is an example of a compounding situation. So at the end of the month, they're going to calculate the interest that you owe, and they're going to tack it on to the principal. Okay, so you end up paying interest on the interest. Excuse me. So what we'll do with that is we're going to take the interest rate and we're going to morph this calculation a little bit. So I'll have 1 plus the interest rate over the number of times that you're compounding per year. So again, this could be twice per year, so that would be a 2. This could be monthly, so that would be a 12. This could be daily, so that would be 365. Okay, this could be hourly, so that would be a big number. Okay, and then we're going to raise that to the n times t. So n times t is going to be the number of compounds per year, and t is going to be the number of years that you're doing it for. So this n and this n are the same. So all you do is take the number of compounds and multiply it by how long you're doing it for. So if I'm compounding semi-annually, that's twice a year. If I'm doing it for 7 years, then 2 times 7 would be 14. Okay, so this is your basic breakdown, and this is the one that we're going to be using the most often in this section. That's going to be the formula that we're using most often in this section. So for the first problem, I have A equals P times 1 plus R over N raised to the NT. And it says, please find the accumulated amount. So A is for accumulated or A is for the amount achieved. Okay. P is present value or principal. R is rate in decimal. N is number of compounds per year. N is number of compounds per year. And T is the number of years you're doing it for. Okay, so I am told that I start out with $2,800, so that's my principal. My rate is 7%, which is actually going to change to 0.07, okay? And then T is going to be for 10 years, and I'm compounding semi-annually, which is twice a year, okay? So that's 2 times per year. So I've just got to fill in all of my information. I'm looking for the amount accumulated or the amount achieved. My principal is $2,800 times 1 plus my rate in decimal form, which is 0.07, over how often am I compounding? Twice per year. And then I have N times T. So twice per year times 10 years gives me 20 times that I'm compounding. And then from there, you can just grab your calculator and shove it in your calculator. So I have 2,800 times 1 plus 0.07 divided by 2 raised to the 20th power. And that gives me an answer of 5571 and 41 cents. Okay. Now there might be a little bit of rounding error. It depends on how many decimal places your calculator takes it out to. So you may get 40 cents or somebody else may get 43 cents. And WebAssign has that tolerance built in because it knows that some decimal places, some calculators can only do 6 decimal places. Some calculators can do 8. Some calculators can do 10. So it will have that built in. That tolerance will be built in for you. Okay, so bottom line is at the end of 10 years at 7%, compounded semi-annually, I'll end up increasing from an initial investment of $2,800 to a total of $5,571.41. All right, so same thing. We are going to do A equals P times 1 plus R over N raised to the NT. And this time my principal is 2,100. My rate is 4%, which again is going to be 0.04. Okay, I'm compounding semi-annually, and I'm doing this for 10 years. So 10 years, and I'm compounding semi-annually, which is twice per year. Okay, so what do I end up with? The amount that I achieve is 2,100 times 1 plus your rate in decimal form over the number of times you're compounding, which is 2, and then raised to the 20th power. So in your calculator, we've got 2,100 times 1 plus 0.04 divided by 2 raised to the 20th power gives me $3,120. So $3,120 and 49 cents, sorry. 49 cents. Okay, so again, what does semi-annually mean? The number of conversion periods or the number of compounding periods per year would be 2. So let's try it again. We have the accumulated amount. So A equals P times 1 plus R over N raised to the NT. And my principal this time is going to be 16,000. And my rate is 6%, which again, in decimal form, these are all money. Okay, in decimal form is 0.06. I'm compounding quarterly this time. So if I'm doing it quarterly, well, that means every 3 months. So that means 4 times per year. And I'm doing this for 10 years. Okay, so the amount that I'm going to achieve is 16,000 times 1 plus R which is 0.06, over n, which is 4 this time, because it's quarterly, raised to the nt, which is 40. So 16,000 times 1 plus 0.06 divided by 4 raised to the 40th power gives me $29,024 and 29 cents. Okay, so let's do a couple more. So I have find the accumulated amount. So my principal is given as 190,000. I am at 4%, which I'm going to convert to 0.04. I am compounding monthly, so that's 12 times per year. And I'm doing this for 6 years. So the amount that I'm going to accumulate, or the amount achieved, is going to be 190 times 1 plus r over n raised to the nt, which is going to be 72. So I have 190,000 times 1 plus r over n raised to the 72nd power gives me 241, 440, and 96 cents. Okay, and again, there's going to be a little bit of give in your software. So if you got 97 cents, it's just important, don't round until the very end. So what I'm doing, I don't know if you can see this, I have an old trashy calculator. Okay, I'm just putting that whole thing in one continuous equation. Okay, and then I just hit enter and it tells me what the answer is. Okay, so let us do one more of this type, and then we'll do a second video and finish them up. All right, so we have principal, which is 1 plus r over n raised to the nt. I am starting with 120,000. Okay, I am doing this at 6%, which is going to be 0.06. I am compounding daily, so 365 times per year. And then I have for 4 years. So unless you're told otherwise, use 365 days for your year. In a lot of business applications, they'll say 360 days per year because there's 5 days during the year that everything shuts down. And I can't remember offhand what they are. I want to say it's Christmas, Thanksgiving, New Year's, and there's 2 other ones, maybe Labor Day and Memorial Day. But there are 5 days per year where the world shuts down. And so no interest is generated, anything like that. So don't be surprised if you're told to use 360. That's actually a common thing. But if you're not told, then use 365. Okay? So I have the amount that I want to accumulate equals the principal times 1 plus my rate, which is 0.06, sorry. I'm compounding 365 times. And I'm going to do that 365 times 4, which I don't even know what that is, and I'm going to let my calculator do it. So just remember when you do that exponent to put that exponent in parentheses. So I'll show you in a second. That gives me 120,000 times 1 plus 0.06 divided by 365 raised to the 4 times 365. Okay, so in my calculator, I said raised to the, and then I put my parentheses around my exponent. If you don't put the parentheses around the exponent, it's going to raise it to whatever thing you type first, and then it's going to multiply your entire answer by the other factor. Okay, so you've got to tell it that entire thing is the exponent. So I get 152,546. And 89 cents. So we'll finish this section up in a second video.